Hello and welcome to our second Astro Pi Mission Space Lab webinar and our first one of 2024. It's a pleasure to see everyone back again for this second session with the mission control team, including Rocket Richard, Galactic Geraint, Nebulous Nick, and myself, Final Frontier Fergus.
Hi.
It's great to be back again, and for the format for today's webinar is a live question and answer style session where we will be trying to answer as many of your questions as possible. So if you have any technical questions, please post them in the chat if you have not already sent us your question.
At the last webinar, we were walking mentors through the registration process, the new guides, and the new Astro Pi replay tool for teams to test their programs. So if you've got any questions regarding those things, please have a look at the recording, which is on our website. But before we get started, we're really pleased to have a real-life space scientist joining the webinar today. All the way from the Netherlands, please welcome Alana Bartolini from the European Space Agency Education Team.
Alana, thanks for joining the session this evening. For the viewers at home, please could you tell us about what you do at the European Space Agency?
Sure. Hi, everyone. Nice to see you all online. Thanks so much for having me. My name is Alana, as mentioned, and I'm the Inspiration and Education Outreach Coordinator for the ESA Education Office.
Thanks, Alana. It's absolutely great to have you here today. And I'm sure there'll be lots of good questions for you from our viewers. But before we dive into the questions, let's have a quick reminder of what space science project the Mission Space Lab teams have been set by the European Space Agency astronauts this year.
Hi Space Explorers, I'm ESA astronaut candidate Rosemary Coogan, and I'm thrilled to see your enthusiasm for the European Astro Pi Challenge, a project run by ESA in collaboration with the Raspberry Pi Foundation. As part of my training at the European Astronaut Centre in Cologne, I'm not only learning how to survive in space, but also delving into the fascinating scientific and technical details of the International Space Station, including its remarkable speed. So let's dive into the concept of speed on the ISS. Speed is a measure of how fast an object moves from one point to another. Up on the ISS, maintaining the right speed is essential to stay in orbit around our planet. Did you know that astronauts on the ISS travel around the globe much faster than any car or aeroplane that you've seen on Earth? But astronauts don't experience those high speeds like we do down here. That's because the ISS, including the astronauts inside, is in a continuous free fall around the Earth. We call this microgravity, and it gives astronauts a feeling of weightlessness whilst they're falling at an incredible speed. I'm very curious to experience this myself in the future when I finish training as an astronaut. But now the big question is, how fast is the ISS actually traveling? That's for you to figure out in this year's Mission Space Lab Challenge. By taking 2 photos of Earth with the Astro Pi camera on the ISS and comparing their location and time differences, you can use the magic of maths and coding to figure out exactly how fast the station is traveling around our planet. I wish you all the best of luck with the challenge, and we look forward to seeing your program run in space.
So there we have it. Mission Space Lab teams need to calculate the speed that the ISS is traveling in orbit, and we believe that there are lots of teams already working on their solutions. Hopefully today we can help you out with any issues that you have faced with this activity so far. Okay, folks, are you ready for some questions? Let's do this. So our first question that we have is I think this is a question for you, Geraint. Can any coding environment be used to develop the team's program?
Yes, thanks, Fergus. Hello, everyone. To answer the question, you could use any coding environment, but we would strongly recommend that you use Thonny because that's the IDE that we support this year. So if you do decide to use another editor, then we can't support any sort of questions you may have with that, but we have on good authority that it does work with, for example, Visual Studio Code. And if you were to feel more comfortable using that, then that's totally fine. So use whichever you're comfortable with. But if you're new to all this, then we strongly recommend you use Thonny.
Fantastic. Thank you. Thank you, Gowan. So our next question is from Team Astronauts in Portugal. And the question is, this is a question for Richard. How can we bootstrap a Raspberry Pi with a SenseHat and camera to mimic the ones on the ISS? Is there an image available we can burn on a card? You're on mute, Richard.
Of course I am. I didn't want to cough when you were speaking earlier, Fergus. Right. Yes, that's a great question. You can absolutely duplicate the operating system and everything that's on board the ISS. The best way to do that is to download a version of the Raspberry Pi OS that's the same as the one running on the International Space Station, and then you can burn that image to an SD card. And I've just got a little clip of how to do that using the Raspberry Pi Imager tool. So first of all, you select the hardware that you've got. So here I'm saying I've got a Raspberry Pi 4. Then you choose your OS. So the latest version, Bookworm, isn't what you want. You want to go down to the legacy operating system and pick the Bullseye version that you saw there, because Bullseye is the version that runs on the ISS. If you want to be completely accurate, you can select the light version. So that doesn't have any of the windowing systems on there. And that's exactly what's on the ISS. And then finally, you just select your storage, your SD card, click Next, and then click No here, and then finally Yes to start writing your card. And that will take a few minutes to run, depending on how large your card is. And then once you've done that, one thing you do need to do is to enable the legacy camera stack. So when you've booted up your Raspberry Pi OS, open up a terminal like this and type this command, sudo raspberry-config. When you're in the menu, scroll down to the interfaces option, and then right at the top you can see it talks about legacy camera, and you just need to enable that. And then once you've done it, it'll ask you to reboot. So reboot the Raspberry Pi, and then you'll have an environment that's exactly the same as the version that's on the International Space Station.
Fantastic. Thank you, Richard. And so our next question, I'm afraid I don't have a team name for this one, but this is a question for you, Alana. And the question is, why is there a limit on the number of photos teams can take on the Astro Pis?
Good question. So there are two main reasons why we need to limit the number of photos that each of the teams can take. The first is that we need to limit the space-to-ground bandwidth that we use. And this is because there is a limit to that bandwidth, which is shared across all of the payloads on ISS, including the science, technology demonstrations, and our education activities. And the second reason is that each of the images that come down from the ISS actually need to be manually checked by someone on the ground and someone within our team. And we do this to protect the privacy of the astronauts and also to ensure that no confidential or private information is visible within the images.
Fantastic. Thank you. Let's see what we've got next. I think we have a question for Nick next. We haven't had any questions for you yet. So this is a question for you, Nick. Which direction does the observation window face on the ISS, and is it at an angle?
It is at an angle, yeah. The ISS is traveling at a fixed position facing the Earth. That is an angle at 51.6 degrees. The station travels from east to west on an orbital inclination of 51 degrees. Each orbit takes 90 to 93 minutes, depending on the exact altitude of the ISS. And during that time, part of the Earth is viewed under darkness and part of that time is under daylight.
Fantastic, thank you. It's such a cool GIF of the animation of the ISS flying over as well. So I think it's probably my turn for a question now. So this is a question from Team Sirius in the Czech Republic, and their question was: is there an interior of the ISS visible in the field of view of some of the images taken by the Astro Pi, and is it likely that an equally limited view of Earth's surface will be available when the program launches in April or May? So I'm just going to share the slides again for this. And Richard, if you could just scroll to the image of the wharf and porthole window for me, please. So this is a picture of the Astro Pis in what's called the World Observation Research Facility. And so when they're in this particular window, there'll be no obstructions. You get a full field of view from the visible light camera. If you have taken part previously in Mission Space Lab, then you would have noticed that there's the images that were taken were actually framed with a kind of porthole. And here you can see a comparison of the two. So the image on the left was taken from the World Observation Research Facility, and the image on the right was taken in, I think it's called the Nadir window. Correct me if I'm wrong there, Alana, but it was a different window facing the Earth. And we
Node 1 or Node 2, Fergus?
Node 1 and Node 2, thank you. And we are very hopeful this year that when the programs run in April, they will be back in the World Observation Research Facility, or WRF for short. So all being well, you'll be getting images with a full field of view. Okay, let's see. Next question we have is for related to the windows still. This one's for you, Richard. And the question is the Earth observation window likely to distort the images that we capture in any way? You're on mute again, Richard.
I'll get it right sometime during this webinar. Great, that's another one of those questions that's really kind of up to you to decide how important that might be in terms of how it affects your program. So this is a graph of the transmission properties of the WRF window. In theory, there's nothing there that should affect your photography if you're using the method we demonstrate in our example guide, where you take one photo, then take another photo sometime later and calculate the difference for it. But if you're using some other approach, this data might be useful. Some other things to also consider is the lens that we're using. So we use one of these lenses here, the Cower 5mm lens, and that in itself does have its own set of optical properties that you can find on the Cower website. And those things there, again, I don't think they'll make a difference for most methods of calculating the speed of the ISS using photography, but depending on exactly what you're doing and how accurate you want to make it, it may be worth having a look at these data sheets and seeing if there's anything there that you need to take account of in your program.
Fantastic. Thank you, Richard. Let's have another question for, I think another one for Alana. The question is, does the ISS stay at the same altitude?
Good question. So no, it doesn't. Actually, the ISS is technically in free fall. So it loses about 100 meters a day, and this is due to air resistance as it's traveling. So approximately once every 2 weeks-ish, they have to fire the thrusters that are at the back of the station in order to reboost it back up into its nominal orbit. So if you go on some websites where you can do some tracking of the altitude of ISS, you'll see that it will kind of fluctuate between around 400 to 420 kilometers. And I know that this is particularly relevant for Mission Space Lab because the altitude is what you're going to be using for the distance part of your ground sample distance calculation. So instead of just calculating it once on an assumed height, you might want to consider getting the altitude from some different sources and recalculating it for each of the photos depending on what the altitude is at that time.
Fantastic, thank you. And it's so good to have you here to talk about some of the technicalities of the orbit of the ISS, Alana. That's such good good information. Going, let's have a question for you now. So this is from Team Martians in Spain, and their question is it absolutely necessary to use any SenseHat sensor in order to get data and calculate the average speed of the ISS?
Hi, yeah, good question. The short answer is no, it's not absolutely necessary. But if your program gets run on the ISS, that's quite a unique opportunity. So we'd recommend that you try and make the most of that opportunity and collect as much data as you can. So if you have time and you're running, you're not running behind in submitting your program, we would encourage you to try and read some data from the SenseHat as well, because you could always use this data or share it with people at school or at home.
That's a really good shout, actually, and it kind of relates to a question that we've had from another team called Team Wormhole in the Czech Republic, which is that they ask, will we present our project, and if yes, how? There's no requirement to present your findings from the data you receive from your program back from the ISS as part of the Astro Pi challenge this year. However, we would definitely encourage you to analyze it and share what you've captured and what you've done with the data with your peers, and to celebrate your success and to inspire other people to take part as well. Let's see what we have next. So this is from a question from Team WJS Astro in the UK. And their question, I think this is one for you, Richard, which is, can we use the color light sensor to detect if the Earth below is covered by cloud?
Great, it's a good question for me, as I've got my flight unit here and notice that I've unmuted myself, so I'm learning all the time. The color sensor is here on the front of the flight unit, but actually the camera and the lens is on the back. So because the lens is the bit that'll be pointing out the window, the color sensor won't be receiving any light from the view of the Earth. So no, you wouldn't be able to use that to detect for clouds. You could have, of course, used the camera and try and work out perhaps by the amount of brightness or a particular color in there, whether the view is completely cloudy or cloudy over water, cloudy over land, that kind of thing. But no, you couldn't use the color sensor for that.
Fantastic. Thanks, Richard. We have another question, and this is from Team Wormhole again in the Czech Republic, but they had a clarification. I think this one is about, it says, how many places after dot each sensor measures. So I think this is how many significant numbers, if I've read that correctly, should they use. Nick, would you be happy to answer this question?
Yes, I would. I had a good conversation with a number of teachers about this one because the decimal places and significant figures are actually slightly different. We're working with significant figures, so that's the first non-zero number in a number. So with the sensor measures that you'll be getting, we'll be averaging it down to 4 figures after the dot. So if your result is 1.2345, you'd want to cut it off at the 4.
Fantastic. Thank you. I see that we've had a question in the chat from TCAS auditor, and I think we've also received this question in advance. So I was wondering if Alana, if you'd be happy to take this one. And the question is the orientation of the Astro Pi relatively to the ISS reference frame LV, LH, XYZ determined in advance for the mission, or is it randomly installed by the astronaut in the front window? So this is how are the Astro Pi positioned in the window? Are they fixed? Would you be happy to take this question?
Yeah, sure. So the answer is actually both. So during the deployment, we always ask that at least one of the IMU axes is aligned with the kind of forward flight direction of travel, with the other two axes that are perpendicular to, of course. So when the Astro Pi is in the Columbus module, this means that the kind of XY axis is usually aligned horizontally and vertically with the edges of the rack front. So if you see actually the Pi that Richard there has in front of him, this means that the Z axis, which is kind of the direction of travel of flight, will be the LED matrix facing the kind of forward direction. When it's typically in the node window or in the wharf window, this means that the camera side is facing downwards towards the Earth. So this means that the Z direction will be going kind of down towards Earth, and the XY axis, either of those will be going towards the direction of flight. But the answer there is that it depends on which orientation the astronaut puts it into the window. So if they put it in right side up or upside down, we don't know for sure. But what we will have is a picture that is taken once they set up the Astro Pi in the window, and we'll get that before the challenge starts, so then we can definitely confirm what the orientation is for all of you.
And Alana, there's a related question to this as well. So that they're in a fixed position rather than floating in microgravity on board the ISS. Is that correct?
Yes, that is correct. So we always have to have the Astro Pis fixed, and usually they're on a movable arm, which is called a bogan arm. And we have to have them fixed to ensure the safety of the equipment that's around them, as well as the crew and for the Astro Pis themselves, because otherwise, if they were free floating, they would be directed by some of the airflow and risk hitting some of the other things that are in the vicinity.
Brilliant, thank you. Okay, let's see what other questions we've had in so far. So I think I've got a question for you, Gowan, and this is from team, let me just get this right, MPD VAT PY in Germany. And their question is, are there ways to load images other than those provided by the system when running the Astro Pi replay tool?
Yes. So in short, no, not at the moment. The Astro Pi replay tool just will replay one set of data and one set of photos. But that doesn't mean that you can't go to our Flickr account and manually download images from previous missions that other teams have uploaded. And you could test your program using those manually. So for example, you could write a function that wraps around the Pi camera function call. So instead of going Pi camera capture, you could have your own function and then make that read from the Flickr images that you've downloaded instead of capturing an image. In that way, you could sort of program your own sort of mini replay tool by yourself. But it's something that we're looking to add in the future to be able to replay more. But for now, it's just the one sequence.
Fantastic. Thank you, Gowan. Please do, as it's great to see some questions coming in on the chat as well. And what we're doing at the moment is kind of taking some from the chat and some from the questions that were submitted in advance. But by all means, you know, any questions or clarifications, please put them in the chat now. The form is also still open, but and we'll just try and get through as many questions as possible during this session. The next question we have is from Team Spacebar in Belgium. I think this is a question for you, Nick. And the question is, could you help us identify which camera, zoom and focal length will be used? Will the focal length be set up by the astronaut in charge of the experiment, and will it be fixed and known in advance? So I wonder if you'll be able to tell us a bit about the high quality camera.
I sure can, yeah. So we're using the Raspberry Pi high quality camera on the Astro Pi modules. They have the Kawa lens that Richard showed a moment ago. It's a 5mm lens. So that's the focal length behind the lens to the sensor is a distance of 5 millimeters rather. The focus is set to infinity, obviously because the Earth is so far away. The aperture of that lens is variable. That will be set by the astronauts during testing after testing to get a good image. And the information or further information on that lens is available on the Kawa website.
Perfect. Thanks, Nick. Okay, let's have a look. What have we got next? We've got a another question from Team Martians in Spain, and their question is this one for you, Richard. Is can we consider that the elevation of the ISS is constant all around the orbit?
Great. Another smart question. I think, again, this is one of those design decisions that you need to take as part of your program. You can make assumptions as to how much any changes in elevation would affect your results. And if you decide you want to try and compensate for those in some clever way in your program, you should do so. But just remember, there's no right answer to this. This is your opportunity to see whether or not you can come up with a program that comes up with an accurate answer for the speed of the ISS. And you can take into account or decide not to take into account as many of these kind of factors as you like in writing your program.
Brilliant. Thank you, Richard. And I think we have something sort of related to that about ground sampling distance. So Gawain, would you be happy to follow up? Because I know that you've got something prepared about ground sampling distance, which I feel would follow on quite neatly after that question.
Yes. Can someone share the slides?
Yeah.
It's the last slide. Yeah. So we've got a couple of questions about how to calculate the ground sample distance, and in short, you can work it out using some trigonometry if you know a couple of things, and those are the focal length, which Nick has just told you about, which is 5 millimeters. And then the second thing you need to know is the sensor dimensions. And we know those because we're using the Raspberry Pi high quality camera. The third thing you need to know is the distance to the object. So that's how high the ISS is orbiting above the Earth. And then you can draw some similar triangles and using some trigonometry to figure out the ground sampling distance. Yeah, I would recommend that if you want to take into account the current elevation of the ISS in your calculations, then maybe you would want to recalculate the ground sample distance beyond that which we've given you already, the pre-calculated one in the project guide. Yeah.
Sorry, Gavin, I found your slide now.
Okay.
I had to refresh the slides because you'd added it before I shared them.
That's okay. Yeah, so here's the slide. So could you make it full screen?
Yeah, hang on.
Right. So there are those similar triangles that I was talking about. So that little blob in the middle is the lens, which is the lens that Richard was holding. And that length L, I'm calling the focal length. And S on the right-hand side is one of the sensor dimensions. So you can see that the Raspberry Pi high quality camera isn't a square, but it's rectangular. One of the sides is longer than the other. So you would, what we're asking when we're saying what's the ground sampling distance is on the left-hand side, what is the H, basically, given that we know D, which is the height of the ISS, L, the focal length, and the sensor dimensions. So you should be able to work out H quite easily with some trigonometry, which I'm sure your mentor will be able to help you with.
And I think if you look online, there are plenty of websites that will enable you just to add in the different dimensions of the sensor, and then it will calculate the ground sampling distance for you.
Exactly. Yeah. So if you wanted to pre-calculate it, you could definitely do that. And for teams that find the trigonometry easy and want to take into account the height of the ISS, they can write their own function.
Super. Thank you very much. We have another question for Alana, and this was asked sent to us in advance. We don't have a team name against this one, unfortunately, but the question is, why can't teams have astronaut interactions with their programs when they're running?
I know, this is a really common question. So these days, recently, the ISS usually has around 7 crew that are on board at one time. And of course, the crew members are extremely busy. So they have tons of different tasks that they have to do through the workday. Just like us, they have a work week and they have weekends. They have to be executing experiments, doing maintenance of ISS. They have to do exercising. So they're super busy, and getting crew time with them is highly competitive because it's very limited and because it's also expensive. So in order to run the Astro Pi challenge, we already used several hours of crew time to relocate the Astro Pi, to set it up, to troubleshoot. And this means that if we were also to ask for interaction with the astronauts during the experiments, we would first have to run way less than what we currently do, which means that many of you would not be able to run your programs in space, which we think would be a real shame. And second, it means that we also would need to do scheduling with the astronauts to have those programs that we have uploaded for flight to actually even be run. And by scheduling, that means that it needs to go kind of into a full system where they look at the priorities and they have to place it in. So it means that there's then a risk that even the programs that we do want to run might not get done because there's not time, and it might take a lot longer than normal. So instead of being able to run the challenge for 3 weeks and have your results, it could be something like we're looking at a 6-month time period where it could be run at any point during that. So it significantly changed the challenge itself, and it wouldn't allow us to run nearly as many of your programs in space.
You're on mute, Fergus.
Thank you.
It's not just me.
No, it's not just you. I was saying that's a real insight into life on board the ISS, Alana. Thank you for sharing that. And next up, we have a question from, I think it's from Astro Nuts in Portugal again. And they asked, Nick, this question for you, I think, can we depend on the Coral, the machine learning Coral dongle to help us calculating the velocity other than using a rule-based image processing process?
Yes, you absolutely can. The Astro Pis do have a Coral dongle attached that you can use. If you write a model to send up with your code, that can be run alongside your code on the ISS.
And on that point, there's some information on the rulebook as well on the website, which you can find here, and it will tell you what file types we allow to in your programs as well. So, for example, for machine learning, and correct me if I'm wrong, Garant, but it's a TS-Lite file type that you're allowed to use.
Yeah, TensorFlow Lite. That's right.
TensorFlow Lite. Brilliant. Thank you. Okay, our next question is for, I think this is another one for you, Geraint. This is from Team Mobius in France. And their question is, do you calibrate the magnetometer to get good measurement of the magnetic field?
Yes, the answer is they have been calibrated, but they are extremely sensitive to changes in the electric field, or changes in electric fields, which cause magnetic field changes and disturbances, and also ferromagnetic material, aka like iron, for example. And whilst we try to control the environment, there's definitely things are moving around in the ISS. So there will be spillover from other activities on the magnetometer. But in general, we think that it's still possible to see the magnetic field of the Earth. Like it's still possible to study it using the magnetometer, even if it is subject to these variations due to its environment.
Brilliant, thank you. And that team have another question as well, which I think is for, let's send this one to you, Richard. And they asked, will you upload the last update of, or latest update that might be, of the TLE file to use with the sky field library to get good approximation of the ISS position before the mission, or could it be an old version?
Yeah, so the TLE file, the two-line element file, is a set of data that the Skyfield library uses to make sure it has the best approximation of the ISS position at any time. And those files do need to be updated regularly. During the Mission Space Lab deployment time, they should be updated at least every 2 or 3 days, maybe more frequently, but it does depend on operator time, exactly how long that will happen. But it definitely will be a very up-to-date version, certainly not one that's a few months old.
Cool, thanks, Richard. I think we've got a quick clarification to make about the angle and the nadir. Nick, oh, actually, sorry, Nick, I saw you're kind of posting in the chat now. Did you want to mention anything about that live?
Yeah,
or
sorry, I'm wrong about the angle. The nadir window is it is pointing straight down to the Earth and not at an angle of 51.6 degrees.
Yeah, so the 51.6 degrees is the declination of the orbit of the ISS rather than the angle relative to nadir. I think you might want to, the ISS is trying to be controlled, so it is always nadir, but we had also, I think, a question sent in to us about this, Fergus, didn't we, about the rotation of the ISS being controlled?
We have, actually, and I think we've got it's a question we've had from a few different people, actually. So in fact, I was going to ask Alana about this because I think this is related. So we've got a question: is the ISS orbiting around a fixed point? Is this the same kind of idea, right?
Yeah, we had a quick chat. I think Jaren's going to take this one.
Okay, fantastic. Go for it.
Yeah, so this is a slightly different question, I think, but we got a question in advance over whether people could use the angular velocity to calculate the linear sort of tangential velocity. And the answer is yes, you can do that. But you might want to consider that the radius is changing over time. So when you are using making those calculations, you might consider doing it multiple times with different radii to get at different answers and see if you can improve the accuracy of your calculation.
Brilliant. Thank you, Geraint. Much appreciated. I see we've got a question from Thomas, which is, if I succeed, what will I win? And we've had something about this in advance as well. So the question from Team Connor in Ireland was, what is the prize for the winner? And the prize, is that you get to have made something that goes into space, which we believe is a pretty good prize, really. So you get to run, you know, if your program works and once we've checked it, it performs perfectly well, then it will get to run in space, and you'll get a certificate of participation. Your mentor will get a certificate as well, and all of the teams who have their programs run on programs are eligible to run on the ISS will be invited to a live Q&A with one of the ESA astronauts later in this academic year. And we'll be reaching out to everybody for your questions to pose to those to the astronaut as well. It's worth saying that we did used to have more of a competition format, and this year it's much more of an open challenge, because we want as many people and as many teams as possible to get the chance to actually have their code run in space and to meet a real life astronaut. So that's why we've changed, one of the reasons that we've changed the format this year. Okay, next question. We have a question for Richard, which is it possible that we could be over the sea with no land features visible for the full 10 minutes our program is running?
Yes, indeed. It is entirely possible that's the case. There's lots of water on the Earth, and equally there's lots of clouds in the atmosphere as well. So you have no control over when in the orbital cycle your program will run, and equally we have no control over the weather. So it's entirely possible that your 10 minutes will be over land, they could be over water, they could be over clouds, they could be over a mixture of terrains.
Fantastic, thank you. Yeah, we have no control over that bit of what the photos will include. We've got a question for Alana, which is, so Alana, you were telling us about the orbit of the ISS earlier, and how it tries to maintain that. So we've got a question from team WJS Astro in the UK, and they're asking how long and how often are the rocket boosters used to help the ISS maintain its orbit, and can these be detected by the accelerometer?
Sure. So as far as the boosts, usually these are done, as I was saying earlier, with thrusters that are at the back of the station. So usually on the Russian side in the Zvezda module. There are also some vehicles that can attach to the ISS, and then they can use their boosters to also add to boost the orbit. And as I mentioned, it's roughly every 2 weeks, every few weeks, they have to do a reboost. And it's interesting, there are some videos online that you can go ahead and take a look at, reboost, which also, this is a tangent, but really nicely shows some demonstrations of Newton's laws. So take a look at that if you're interested. As far as if the Astro Pi can detect this, that has to do with the sensitivity of the accelerometer. Richard, I don't know if you can recall in the past if we had teams that were able to successfully capture a reboost. Can you remember?
I believe we have, yes.
So there you go. If you're lucky enough to have the period of time, and usually you need kind of the full period of time, which is, you know, around 10-ish minutes, you can see the change within, but it has to be kind of within the full length of your program running.
Fantastic. Thank you, Alana. Excuse me. We've got another question from team MPD VAT PY in Germany, and this, I think, is a question for you, Gawain. Your question is, when we run the command location equals ISS dot coordinates, brackets dot coordinates brackets in the Astro Pi replay tool, we always get the same data. Is this related to the simulation, and can it be adjusted to the current ISS position data?
Good question. So I discussed this a little bit in the last webinar, but what happens when you run your program using the replay tool is that it actually replays the same sequence of data and photos every time. So Correspondingly, it also replays the same sort of TLE data. So that's the coordinate data for the ISS, which match the photos in the sequence. So if you were to rerun your program multiple times using the replay tool, you'll see that indeed the coordinates are very similar, because at the point of time which is being replayed, the ISS was a specific range of coordinates, which is just replaying. If your program gets to run on the Astro Pis on the ISS, however, the coordinates will just be the coordinates of the ISS currently, rather than a replayed version. So you'll expect to see them change every time you run, because instead of replaying data, you're getting live data. So the live coordinates of the ISS are changing.
Brilliant. Thank you, Gowan. We've got a question here from Suchibrata Kar on the live chat, and I wonder if this is a question that Gowan or Richard, whoever would like to take this question, is there a library which can find the location of where a photo is taken from, and what would you suggest to do if the full 10 minutes is over the sea? Who'd like to take this one?
There are two questions there, but I will take the first
sub-question.
Is there a library which can find the location of where a photo is taken from? There are multiple ways you can answer this question. The easiest, and the one that we've done before, is to use the Orbit library, which is built into the Astro Pi environment and also into the replay tool, and to use the ISS coordinates function, which is outlined in the creator guide. So if you have a look at the creator guide, you'll see that you can get the current location of the ISS. As for finding like the name of the location, that's a little bit of a different problem, but there are Python libraries available if you wanted to do that another time.
Fantastic, thank you, Gowan. And I guess the second part of the question, what would you suggest to do if the full 10 minutes is over the sea?
I can answer that if you like. So I guess I think
thank you.
I think when we've looked at Astro Pi data before that's been taken with the camera, it's very rare that for more than a few minutes you have a view that doesn't contain some kind of feature. Now that might be land, or more likely or not, it will be clouds. It's very, very unusual to just get the calm sea below you and nothing else. So I think in your 10 minutes, there will be features that are visible in pictures. And so I think the thing to do is to make sure your program is smart enough to work out when it can't find useful features to use, and look for opportunities for when there are more interesting things in the images, and use those and calculate your speed based on those ones.
Excellent, thank you, Richard. We are getting close to the end of this webinar now, so if you have any more questions, please do put them in the chat. We've got time for probably just a couple more now. There's a question from Fred. Excuse me, where the photos should be saved. Is there a particular folder to save them to? We have lots of instructions and information about that in our rule book and our creator guide, so I would point you towards those. Here are the rules, a link to those, and you can find how to kind of structure and organize your folder structure and everything so that it will work in there. We have one final question that we were sent in advance. Garen, I think this is probably a good one for you, because this is very much about the code itself. And this is from Team Cosmic in Germany. And they would like to know, are they allowed to split up our script into multiple .py files for better legibility, as long as it still runs using the main py file?
Yes, the answer to that is yes, you can do that. And yeah, that would be encouraged if you have a very large code base to do that.
Brilliant, thank you. So we do have one other question that we received in advance, and I think maybe this will be a fun one for us to end on, and it'd be great to get your thoughts on this as well, Alana. If I could just ask Richard to share his slides. So the question from the Perse School in Cambridge is, do you think AI will develop at such a rate that it beats humans to Mars? It's less about the project guides and things, but well, I think we had to think about this, and we thought that we should probably also ask ChatGPT to tell us what it thinks about it as well. And what we quite quickly found out is that artificial intelligence technologies are already being used on Mars in the Perseverance rover, and also the Curiosity rover, to help it with some of the identification and navigation amongst other systems. So in a way, it's already there and being used. I don't, but ChatGPT did say that it will, help with the kind of efficiencies, but ultimately it's very much a collaboration between humans and artificial intelligence that will enable us or more space travel to Mars. Alana, being in the European Space Agency, I guess you must be seeing a lot of artificial intelligence starting to affect some of the technologies and developments in space engineering and space science.
Yeah, it's a good question. It's interesting. We certainly already are using AI in various different fields. Even on ISS, they've been testing things like potential crew assistance or, reviews medical data and things like this. So it's certainly already in use, and it's going to, I'm sure, continue to be of use and probably grow even more in the future. With regards to the kind of explicit question of whether it will beat humans to Mars, I think that, of course, we have to remember that there's major components of space travel that still are required to have human kind of interference within it. So, building actual physical items, of course, you can have robotic help, but we still have engineers designing them. We have people who are, doing the safety checks and things like this. So I think it's certainly something that is going to be more and more common. We're going to see really new, interesting uses of AI. But I kind of agree with what ChatGPT said there, that I think it's going to be a collaborative effort between us together with AI.
Fantastic, thank you. I think we have just one final question that I've seen in the chat. Let's just see if we can respond to this one quickly, and then I think we will wrap things up for this live stream. But the question is from Fred once again. So he's asked, how frequently will the photos be taken? Photos using the Astro Pi replay tool take roughly 15 to 20 seconds. So will it be the same on the ISS? I think the short answer, Fred, is that it's kind of up to you, because you're going to be writing the program yourself, so you can determine the frequency. But please bear in mind that there is a limitation on how many photos you will be able to receive. That's capped at 42. So do refer back to the rule book and the guidelines that we've the rules that we've written for the challenge.
I'd just like to add to that it depends on which resolution you choose, how fast the processing works. So if you choose to use maximum resolution, the fastest you could take photos, even with if you just had a program that said capture photos as quickly as possible in a for loop or a while loop, you'd see it takes roughly 2 to 3 seconds per photo because it's having to process all that data. But if you chose a smaller resolution, you'd find that it goes a lot quicker. The replay tool, yes, currently replays images every 15 to 20 seconds. And that's something that we would hope to reduce to be more in line with the behavior that you see on the ISS. So for next year, the replay tool will be between 2 and 3 seconds.
Fantastic. Thank you for the clarification, Geraint. Okay, well, thanks everyone for all of your questions and comments today. It's been great to have so many questions, in fact. It's been really good to hear about some of the issues that some of the teams have encountered so far, and we hope that we've managed to resolve some of these for you as well.
And as ever, if you've got any more questions, please get in touch by contacting us at contact@astropi.org. Please note that new email address, which you can find on our website and guidance documents, but don't worry, the old one will still work as well.
And don't forget that the deadline for registration and program submission is 9 a.m. GMT on Monday, the 19th of February. So you've got plenty of time to get your program working, but do make sure you leave time to test your program before you submit it.
So thanks to the team for your excellent answers today. And once again, a special thank you to Alana for joining us this evening from the European Space Agency.
Thank you all. It was really a pleasure to be here. And for everyone watching online, just wanted to wish you luck. Again, hope that you have fun doing your submissions, and we look forward to seeing them.
Indeed, good luck and have fun with the remainder of the mission. A recording of this webinar will be available on YouTube to watch again, and we will also be adding it to the astropi.org website very soon for Mission Space Lab pages, and we'll also be adding the Getting Started with Mission Space Lab webinar to the website as well. But for now, it's goodbye from everyone here at Mission Control. Goodbye.
Bye.
Bye.
Bye, everyone.